Hi guys, today's lesson is about exponential growth and decay. This is when things are growing at a constant rate or they are decreasing at a constant rate. Now, this is just an extension of exponential functions. So you already know the exponential form. You know that a is the initial value, which gives us the y-intercept, and b is the factor, and this is what is going to be the rate. And in when we have b is more than 1, then it is a growth factor. That means it's growing more than 1%, more than 1. And less than 1 means it's slowing down, or it is a decay factor. So, how do we know if it's a growth or a decay factor? We just want to make sure you understand all of this. Y is the output or the result. X is the input. It's the number of times that something is happening. A is the initial value. B is the rate. And depending on what the rate is, it could be a growth or a decay factor. So once we know the rate, we do 1 plus R, and that then it becomes growth. Or once we know the rate, if it's going down, then we do 1 minus R, and that becomes the decay. So in other words, you could think of it as B being replaced by 1 plus R if it's growth. I just want to put an X here. X goes here. And if it's a decay, then it will be 1 minus R. And the X goes here. And so I want you to understand that this is just a variation of the exponential function. So I'm going to put up a few factors, and I need you to recognize whether it's a growth or a decay factor. Remember, growth is going to be more than 1, and decay is going to be less than 1. So the first one says b is equal to 1 minus 0.3, which is going to make it less than 1. Therefore, it is a decay. The next one says it's 1.05, which is more than 1. So it is a growth. The next one is 1.07, which is more than 1. So it is a growth. And the last one is 0.93, which is less than 1. Therefore, it is a decay. So most of the problems you're going to do on exponential growth and decay are going to be word problems. So here's an example problem. In 1985, there were 285 cell phone subscribers, and the number of subscribers increased by 75% each year. That means every year it's going up by 75% more. How many cell phone subscribers were in the town in 1994? Write an expression to represent the equivalent monthly cell phone subscription increase. So there are two parts to this question. You have to write an expression, and you also have to find how many people there were in 1994. So the initial value here is 285. The rate is 75% each year. So it becomes 1 plus 0.75. The expression becomes y equals 285 times 1.75 to the power of x. Don't forget to define your variables. X is the number of years after 1985, and y is the number of subscribers. And then to calculate what will happen in 1994, you're going to substitute x is equal to 9 and use your calculator to give me this answer. Let's try one more. I want you to give this a try before I reveal the answers. In this case, a kilopascal is a unit of measure for atmospheric pressure. At sea level, it's about 101, but for every 1,000 meter increase, it decreases by 11.5%. So it turns out that y is equal to 101, and since it's a decrease, it's going to be 1 minus 0.115 to the x. Don't forget, x is the number of times we go up every 1,000 meters, and y is the kilopascals. That's your expression. And when it's 3,000 meters, x is going to equal to 3, and it's going to be approximately 70 kilopascals. That is it. See you in class. Goodbye.